So as we start moving into pathway metabolism, we'll focus heavily on the homeostasis of glucose. And this is controlled primarily by four major hormones. First, insulin, which signals through a receptor tyrosine kinase, glucagon, which signals through a G protein coupled receptor, cortisol, which binds an intracellular receptor, and finally epinephrine, which signals through an additional G protein coupled receptor. So the interplay between these four hormones is essential such that we maintain glucose homeostasis in a very tight range between 80 mg per deciliter to 120 mg per deciliter. So let's start with insulin in the fed state, because insulin is going to be elevated under conditions when you've just eaten. So let's first look at what happens to dietary glucose. So dietary glucose can either be oxidized or it can be stored in several forms. So as glucose is taken up by our tissues, insulin will increase the activity of glycolysis. This will ultimately generate pyruvate, which is used to make acetyl-CoA, and that's oxidized in the TCA cycle. We also have several other anabolic pathways occurring, namely glycogen synthesis to store excess glucose, as well as fatty acid synthesis. We'll also have cholesterol synthesis upregulated when insulin is high. Protein synthesis is also occurring as an anabolic process. So as we've just seen, excess carbohydrates and amino acids, as well as what we'll see are dietary fats, will be stored through esterification in the adipose tissue. So insulin will increase the storage of dietary fatty acids, as well as the synthesis of de novo fatty acids through the process of lipogenesis. When insulin is high, dietary amino acids can be used for both protein synthesis as well as through a process referred to as transamination. And we'll discuss this quite a bit in later units, but essentially the process of transamination allows for the removal of the nitrogen group from amino acids such that the remaining carbon skeletons can be oxidized to produce energy. We'll learn later that that nitrogen is used in the process of the urea cycle to generate urea. So if we transition now to looking at glucagon, which is a hormone elevated in the fasted state. So glucagon is a catabolic hormone which will now allow us to break down our stored fuels to be used as both energy and for glucose homeostasis. So glucagon has several primary roles, the first of all initiating glycogenolysis, as well as producing glucose through the process of gluconeogenesis. And our substrates for that gluconeogenic process come from tissue proteins, which are converted back into free amino acids, and the carbon skeletons after transamination are used to produce glucose. So again, glucagon has two primary roles related to glucose homeostasis, both the release of glucose from stored glycogen as well as the synthesis of glucose through the process of gluconeogenesis. In contrast to insulin, glucagon also stimulates the release of stored triacylglycerols into free fatty acids, and this is through the process of lipolysis. What we'll see later is that these free fatty acids are used by several different tissue types in the fasted state through a process of beta oxidation, which allows us to generate acetyl-CoA as well as ATP for energy. And finally, both epinephrine and cortisol are also elevated in the fasted state. Cortisol is primarily responsible for initiating protein catabolism. So again, protein catabolism will be needed to supply carbon skeletons for the process of glucagon-mediated gluconeogenesis. Epinephrine is a hormone that primarily enhances processes, and epinephrine will enhance the process of both glucagon-mediated lipolysis as well as glycogenolysis. So let's finish with a quick question. Which of the discussed hormones is considered anabolic? So let's look at the terms anabolic and catabolic first. So anabolic is considered to be a building hormone that builds molecules or stores resources. In contrast, catabolic really refers to the breaking down of molecules or the subsequent dismantling of stores. So when we put it in those contexts, the hormone discussed that's anabolic would be insulin. Insulin is used to store excess dietary fuels such that they can be used in the fasted state.